Hi everyone, my name is Nikhil John. Welcome to the webinar of Achieving MLOps with Kubeflow with myself and Tahir and Royal Cyber. So this webinar, what we would like to showcase to you is how we would use Kubeflow as an ML operations to simplify your entire workloads around machine learning. A little bit about us, Royal Cyber. We are a 1500 plus member company across 10 plus locations. We have a big cloud practice. We have over 300 people working in cloud, most of them certified on AWS, Azure, Google, IBM, Oracle, and all other clouds. And we also have a large open source practice where we specifically work on open source tool sets, DevOps tool sets, DevOps tools specifically that can help you out. And Kubeflow is one part of it, which we really work on. If you want more details, you can shoot out an email to us to know more about what we do. To give you a little brief about the webinar, myself, Nikhil John, I take care of growth at Royal Cyber. Tahir will be introducing himself. Tahir is a solution architect. He used to lead the DevOps team at Royal Cyber. And I specifically am responsible for cloud practice. And where we would like to take you through is a detailed agenda of Kubeflow and what we can achieve using ML operations as a service, right? So this is the detailed agenda. My part specifically is around why MLOps, what MLOps, when do you actually implement MLOps, and where exactly do you operationalize with Kubeflow. We will try to take you through some use cases and demos as well to make it real for you. So moving straight in, what and when. So this is a typical MLOps cycle where we define the use case, do the exploration, select the algorithm, hyperparameter tune, evaluate the model, run it in production, operationalize it, and then go through the whole loop once it again, right? So to make the model better, you keep iterating till the model gets better. Now, this entire cycle of ML is quite cumbersome, right? So you have to deploy your code, you have to manage your data, you have to explore your data, you have to do the feature engineering, you have to train your model, see whether the training data is actually giving you the right amount of results, look at the accuracy, you have to maintain the logs, see the logs that are working well or not, whether the model is actually fitting, and all of those little details in machine learning operations. And then the prediction cycle of things, right? And that whole part where you have to continuously optimize the code, that's where it makes it very difficult as a continuous operation. So here, ML Ops, what we are trying to do is essentially get in the data engineering, the software engineering, and the data science part of it, which is the model building, all together in one core system, right? So data engineering specifically with the data pipelining, automated data pipelines. We create MVPs or MVM, minimal viable models in the model prototyping. And the software engineering part of it, we took a cap out of the DevOps cycle where we do CI/CD, which is essentially continuous improvement, continuous deployment. And that's the whole aspect of machine learning operations, right? That's what we do. Now, what is it exactly? A definition of MLOps is where the culture of ML engineering and the practice that aims to unify the development and the operations. Just like DevOps, MLOps is a culture, right? You have to imbibe that culture within your developers so that they continuously improve on whatever they're deploying. It is continuously as a delivery process, they are making sure that the operations continue. And it's strongly advocated if you have built your 1-2 models. Now when you are moving your models into production, this is where it becomes real. So we advise this for most of our customers. What are the steps, right? So we follow multiple steps. Some of the steps which I've listed here and much more detail probably while you are implementing on cloud is the extraction of data, the exploration of data, the transformation of data. The cleansing part will come into this stage. You train your model, you evaluate your model, you serve your model, and then you monitor your model based on whatever predictions you're getting. Now these entire steps, you involve the continuous integration aspects of things, which means that you check your code, you complete your task, you check your code base, you perform the testing, all of those related details, your continuous delivery, your CD part of it, where you build, test, and release continuous basis. And then the new part which we are bringing in is about continuous training. right? So MLOps also signifies the monitor, measure, retrain, and serve model, where you continuously improve on the training so that you get a better feedback loop into your model. Now, to summarize what we do in MLOps is development, deployment, and operations, right? So the data processing, the model deployment, the model development, testing, and validation, the CI/CD part of it. I told you a cap of the DevOps cycle, the integration, the deployment, the monitoring and testing, and the entire feedback loop aspect of things. So, when do you consider it? What we believe is that if you have deployed an analytics model, a data science model, maybe you have reached a stage of familiarity with how you build the model, the entire model production. You've reached, you evaluated your results, you are getting a decent level of accuracy. Now you want to take it a step further. This is where MLOps comes into the picture, where you formalize it, you operationalize it in a way where it is continuous. So this is the stage where you should consider using tools like Kubeflow, which is the core of where MLOps exists. So now I would like to pass the mic to my colleague here, Tahir, who's going to take you through machine learning operations and Kubeflow, specifically a tool which is an open source tool used for machine learning operations. Over to you, Tahir. Thank you so much.
Hi everyone, and thanks Nikhil for the brief explanation of over ML Ops. My name is Tahir Javed and I work here as Solutions Architect. So today I'll be deep diving into Kubeflow. I'll be discussing what Kubeflow is, what is the architecture of Kubeflow, some of the components of the important components of Kubeflow, and then we are going to see the components in action with some examples. So what is Kubeflow? Kubeflow is basically software uh, compiled, which consists of many ML related tools. It's a unified software consisting of many ML related tools, which makes the deployment of machine learning workflows simple, portable, and scalable on Kubernetes. So under the hood is Kubernetes. This is the architecture of Kubeflow. So let's start from the very bottom. You can see that Kubeflow can run on uh, public clouds like GCP, AWS, or Azure, and it can also work on on-prem cloud, for example, OpenStack, and also locally on your laptop. All it needs to have is Kubernetes on top of it, because under the hood of Kubeflow is Kubernetes. Then above Kubernetes, you can see the components of Kubeflow, like Jupyter notebooks, several operators, and KF serving, user interface, pipeline, fairing, hyperparameter tuning. So we'll be seeing the important ones. We'll be discussing about the important ones. So this is a summarized architecture where I have mentioned the important components. Again, you can see at the bottom that you can have Kubeflow, you can install Kubeflow on public cloud and even on on-prem either on VMware or OpenStack. All you need to have is Kubernetes or OpenShift. Kubeflow is actually bundled with Istio, Prometheus, and Grafana. So there are many benefits of Istio, and there are all the benefits of Kubernetes and Istio are actually inherited to Kubeflow. So Istio gives you the capability of traffic management, observability, and security, while Kubernetes gives you the advantages like auto scaling, self-healing, and automated rollouts, service discovery, load balancing, etc. Prometheus for monitoring, and Grafana to provide you the visualization. So the top layer is the Kubeflow, and Kubeflow has many components like Jupyter notebooks, many model training operators. Here I've just mentioned the TensorFlow one. For hyperparameter tuning, the component is Katib. For pipelines, it has a component called Kubeflow pipelines, but under the hood, it uses Argo. It translates into Argo templates. Kale for deploying your model directly from Jupyter Notebook or converting your code into pipeline, KF serving for model serving, and it's further categorized into many tools like TensorFlow serving, PyTorch, Selden Core, and then some miscellaneous important components like fairing to convert your code into Docker image. And from that Docker image, you can launch the container, a user interface for a portal for experiments, metadata, and server. You can also go for serverless approach with your models and training jobs. So let's look at the important components like Jupyter Notebooks. So it's a web application that allows you to create and share documents um, on Kubeflow. And there are many benefits of having a centralized Jupyter Notebook server on Kubeflow, like it gives you the access control. You can share your notebook among within the organization. And then you have model training operators like TensorFlow, Job, PyTorch, etc. So again, it's upon your choice that and your choice and the data engineer's choice on which platform he's feasible in developing. Katib, it's a tool for hyperparameter tuning, so it gives you the interface where you just provide the parameter values, and then it's going to run several jobs, the training jobs, and going to select the one which has the highest accuracy. So it's a very useful tool. You just need to provide proper annotations into your Jupyter notebook, and everything is going to work automatically. So we will see uh, the live demo where I'll show you the example of Katib and, and other tools also. So Kubeflow pipelines, this is how it looks, as I told you before. So Kubeflow pipelines, if you're familiar with Python and a little bit Docker, you can easily write down the templates. Or if you're familiar with the Argo templates, because under the hood of Kubeflow pipeline, it translates to Argo, which orchestrates which the Kubernetes containers. So this is how the interface of pipelines look like in Kubeflow. Kale is actually a very useful tool for data scientists to which is actually required to orchestrate end-to-end ML workflows. So Kale provides a user interface in the form of Jupyter Lab extension. Again, just like Atib, you have to provide annotations into your Jupyter notebook, which I'm going to show you the examples, how the annotations are provided into the examples. And then it's going to convert your Jupyter notebook into pipeline automatically without writing even a single line of code. KF serving. Again, KF serving has, you have many options to serve your models on Kubeflow. Like you can serve using TensorFlow, PyTorch, etc. So I'm going to show you an example of a model using TensorFlow serving. And so Kubeflow is bundled with Prometheus and Grafana. So you will get the monitoring of your infrastructure, the containers out of the box. You do not have to configure any monitoring. But in order to monitor a model specifically, for that you have to write down, you have to use some open source tool and use its libraries and write down the scalars accordingly. So I'm going to show in my example, I have used TensorBoard, which I'm going to show the example. The same way, in the same interface, you actually see the real-time logs of your model, which is being served. So again, this is the out-of-the-box solution. So this is a typical CI/CD in Kubeflow. Now these stages can be add or removed as per requirement. So if you see from the left that ML engineer maintains its machine learning code on some on version control system. So you can write down a pipeline accordingly that first check out the ML code, do data load, data transformation, feature engineering if required. Model training is definitely be required, model validation, and hyperparameter tuning if required. And then when it comes to serving part, you need to convert your code into Docker image, and then that using that image, it is being served into the Kubernetes environment. Let's see some of the use cases of Kubeflow. Like Kubeflow allows you to choose what is right for your project. For example, frameworks, tools, libraries. As I told you before, it's a bunch of different ML tools. It deploys you to manage a complex ML system at scale. So it provides you the scalability options. That is, if your uh, number of models or training jobs are increasing, the system will auto scale. And when it gets decreased, it's going to again come back to its original value. In this way, you can save costs. Experimentation with training and ML models. So it provides you an interface where you can track your experiment, schedule your experiment, end-to-end hybrid and multi-cloud ML workloads. So because it is based on Kubernetes, so you can have different worker nodes on different places, for example, on GCP, AWS, and some of them can be on-prem, so you can schedule your workloads accordingly. Hyperparameter tuning using Katib. So we'll see in example then how hyperparameter tuning helps you. Continuous CI/CD, again, it is a feature of Kubeflow that you automate the whole life cycle using CI/CD for ML. And again, it inherits the benefits of Kubernetes, which we have discussed earlier, like health checks and rollouts, etc. And also it inherits the capabilities of Istio. So I have a couple of demos um, in my lab, but we will see a few of the important ones. So let me switch my screen. This is how the interface of Kubeflow looks like, and installing the Kubeflow is very easy. So on the left, you can see the options. We will discuss some of the important ones, like notebooks. It provides you a centralized way to host your notebooks, and you can share the notebook servers among different developers. Tensor board, because I have an example, that's why I've installed it. And then models. So all the models that you deploy, they'll be appearing over here where you can do monitoring or do management. Experiments, so you can schedule and track all your experiments in this environment. Pipelines, again, you can manage the pipelines over here, and you can explore also. So runs, that how many times the experiment got executed. It has a whole log over here. So these are some of the important options of Kubeflow. So let's see by example. Let me show you an example of end-to-end deployment of MNIST dataset just through Jupyter Notebook. On the left, you can see that this is the model file and this is the notebook, which is deploying an MNIST model. It's deploying, training, creating Docker image, all through this notebook. So we'll discuss the important steps. Like the step number one is to use Kubeflow fairing to build the Docker image. So you can see here that the fairing library is imported over here. And this is how the template looks like, where you just mention details about your Docker image, Docker registry, and pass the uh, uh, pass credentials through environment variables. So here are the logs that it created, the Docker file, sorry, the Docker image, which will be used later. The another step is training. So this example is using TF job as discussed earlier. Let me go back to the slide. Model training operators. There are many model training operators like TF job, TensorFlow training, PyTorch, MXNet, etc. So this example is using TF job. And this is how its template looks like. Here in Kubernetes, you define the kind. So here and the API version. So you can see here the kind is TF job, and it has all the parameters required to run this training job. So you can see here uh, it's executing a Python command in the OPT model py with these arguments. After that, the important step is to serve your model. And here you can see. Okay, so this is here. You are serving the model, and I'm using TensorFlow serving. So again, there are many tools, many options to serve your model. But in this example, it's using TensorFlow serving, and this is how the manifest looks like. And it's serving in a very simple way. That is, the kind uh, is Kubernetes deployment, and API is apps v1. So it's if you see over here, these are the arguments. This is the uh, command, and these are the container ports. It's similar the way you write down the Kubernetes manifest. And once everything is done, so after serving the model, the final step it's doing is that it's deploying the UI, user interface, which will actually talk to that model. So if I go to the terminal, I type command kubectl get pods, you will see here that it launched some containers. It trained the models, and then those containers are gone. So after training, it has launched the model, which is running. And once the model is running, then it has launched a user interface, a front end, which will actually take values from that model. So this is the URL of the front end. And this example is open source, so you can also check out its GitHub link and deploy on your own lab. So here you can see that this is the front end, and it's talking to this model server. This is the port number. This is the server address. So if I refresh the page, it's going to load an image and do a prediction. So right now it has done a wrong prediction because the models are not 100% accurate always. Now it has done right prediction. 0, image is 0, and it has detected 0. This time again, right prediction. And um, this model is using TensorBoard specifically for model monitoring. So it has using TensorBoard libraries and has generated a scalar, which is showing Q input. On the other hand, you can also do visualization through TensorBoard. So this is actually very helpful for data engineers. They understand it very easily. So the purpose of this example is that you can do end-to-end from development to serving just through this notebook in this platform. Now let's look at some other components of Kubeflow. Let's look at Kale, how Kale works. So I have one more example. So as I told you before that Kale simplifies the use of Kubeflow. It gives data scientists uh, the way to orchestrate end-to-end ML workflows. It gives an easy way. So it will provide you a UI in the form of Jupyter Lab extension. You just need to provide proper annotations into the cells of Jupyter notebooks. So this is my notebook, and I will show you that how annotations are done over here. So if once you install the Kale uh, in your environment, an icon will start appearing here. So right now you don't see any annotations. When I click on enable, you will start seeing the notions. So the one which you wanted to skip into your pipeline. So what Kale is serving right now, the purpose of Kale or in this notebook is that it's converting your notebook into a pipeline. So let me open the pipeline on the another window. If I click on this pipeline, this is actually created by Kale. It's not created by me. Now, Kale is just executing your notebook steps, but how Kale knows what to execute is through Notion. So here skip means that don't include this in pipeline. Now, this means include this in your pipeline. So if sorry, this one is not, okay, this one. So here you can see that step load underscore data. So it means include this step into your pipeline. And here you can see load data is included. Now another step is detect dog. And again, you can see the notion over here, detect dog. Now there are 3 more steps like CNN from scratch, CNN ResNet, CNN VGG. So you will see the notions accordingly, like here, CNN from scratch. And also you can do that. It depends on this one, the previous one, like CNN VGG depends on the green one, like on the previous step, the step which has this green label. So it's just the game of notions. The steps you wanted to include in your pipeline, just note them, install Kale, import its required library, and click on enable. And simply run, compile and run. It will automatically create this pipeline for you. But what if you don't want to do it with Kale? You wanted to create it manually, then you have many options, but I'll discuss the 2 important options. So one is the Kubeflow pipeline library. For that, you need to actually know about Python and a little bit Docker. And it's a DSL. You just need to put parameters required to execute your stages. And the other option is the using Argo templates. So Argo templates, because if you're going to write down pipeline in Kubeflow pipeline, at the end, Kubeflow is going to convert it into Argo, Argo manifest, and it's going to look like this. Here it's looking a little bit complex because it has too much metadata and other information which is not required. But if you are familiar with Argo, you can write down the template accordingly. Like here, the API version is Argo project.io. Kind is workflow. Arguments, command, Python 3, and all the arguments together. So it depends upon your choice. If you wanted to go with the easy way, use Scale. If you wanted to write down uh, Kubeflow pipeline templates, you need to be a little bit familiar with Python and Docker. And if you are familiar with Argo and Kubernetes manifest, then you can write down the YAMLs accordingly. So this is how Kale works. Like it's going to convert your code into pipeline. Let's look about Katib now. So the same way Kale works, Katib works the same way as Kale works. So the main purpose of Katib is hyperparameter tuning. They are the variable that controls model training process. Hyperparameters are those variables. So all you need to do is that your pipeline should have one notion. So this pipeline parameters. This is all you need for hyperparameter tuning. Now here you can see that there are two hyperparameters, node numbers and learning rate. Now you need to change these parameters and retrain your model accordingly. So just provide this notion, install the required parameter packages of Katib and import the library into your uh, Jupyter notebook. Click on enable, click on setup Katib job, and this is how the user interface will appear. It will automatically fetch these values like the node numbers and learning rate. It will automatically fetch from this notion. So here you can see that you can modify the range and modify, you can provide several values, and then the experiments are going to run multiple times upon with these values. So you can also check this on Kubeflow experiment. Like here, you can see that upon providing these hyperparameter values, it executed these numbers of experiment. And it will also show you the precision rate, the test accuracy. Like the last one has 82.5, 81, 83. So last uh, multiple experiments will be executed as per your hyperparameter, and it's going to select the one which has the best accuracy, and then you can uh, serve it accordingly. So this is the example of how you can use Katib and or what you can leverage the benefit from Katib and Kale. Now let's look at model serving. So I have served a model which is called Open Vaccine, and it's using TensorFlow serving. So you can see here the runtime is TensorFlow 2.3.0, and it has a YAML. You can see that it's very much similar to Kubernetes manifest. Again, you can see the API version kind for Kubernetes service like inference service. Out of the box, it provides you monitoring. So if you click on metrics, it will tell you the CPU, memory, and request, etc. of what's going on with your container, and real-time logs. See here. And so this is the YAML. This is manifest uh, in order to serve your model, but you can also use Kale to like, for example, if you are serving through your notebook, again, you can define this, provide an notion to Kale, and Kale will do this automatic for you. Like it's going to create this deployment manifest for you following that notion. So let's see what we have next. So we have talked about Jupyter notebooks, model training operators, Katib for hyperparameter tuning, Kubeflow pipelines, and Argo. Yeah, so I've already shown you how what options you have. Like you have the option to go for Kale for Kubeflow pipelines using Python and Argo using Argo templates. Kale for converting your Jupyter notebooks to pipelines using notions. and KF serving. So we saw an example of TensorFlow serving. And then we see the out of the box monitoring and logging. Now, in our upcoming webinars, we'll be discussing about more other features like Istio, how we can leverage the Istio features, as Istio provides you traffic management, observability, and security capabilities. And then there are more add-ons, external add-ons like Elira, which is again an open source component, and it gives data scientists uh, uh, the benefit to create workflows all visually. So that's all from my end. Now, Nikhil, it's all over to you now.
Thank you so much, Tahir. This was a great session, very informative about Kubeflow, each and every aspect of it. How do you train your model? How do you deploy a notebook? How do you write code? How do you create the pipelines, the orchestration part of the pipelines? I think that was awesome, right? So I hope you all got a complete idea on what is the possibilities of Kubeflow and how you can reiterate and create the kind of MLOps framework or thinking around, having a tool like this in place and how you can continuously improve.